Okay, this lab is for my pre-calculus class, and this is trig equations involving more than one function. And in the front of your packet, you have a yellow sheet that has all your trig identities on it, so you want to get that out while we do this. I will be referring to it as we go through this. So this part of the lab, I'm looking for all the numbers between 0 and 360 degrees, so this is in degrees. And we're going to start out a little bit differently than what you're used to. It's because we're going to start actually putting these in all-in-one trig function. So before, all the trig equations that you had were in one trig function. But do you see where I have a sine squared here and a cosine here? So I've got to try to get it all in one trig function. When I see a sine squared like that, I think, is there an identity that I know of? So I'm going to bring up my identities. And I do know my Pythagorean identity that cosine squared plus sine squared equals 1. Well, if I'm trying to figure out what sine squared is, if I subtract cosine squared on both sides, I would know that sine squared of theta is going to equal 1 minus cosine squared of theta. I just solved for sine squared by moving this over there. If I know that, I can put this in that spot where sine squared is, because sine squared equals that. Then my whole equation is going to be in cosine. All right, so let's go back to our lab, and I'm going to put 4 times what we just found, which was 1 minus cosine squared of theta, plus 4 cosine theta, minus 5 equals 0, because I know I'm going to have to put it equal to 0, okay? Now I'm going to use a distributive property. So I have 4 minus 4 cosine squared theta, plus 4 cosine theta, minus 5 equals 0. Now I notice that the cosine squared is here and the cosine here. So I'm going to put this first, second, and then I'm going to combine the 4 and negative 5. So I have negative 4 cosine squared theta plus 4 cosine theta minus 1 equals 0. Now right here is what we've been doing, is I've been giving it to you like this, and then you go through and find your angles. So now you actually have to work on it using identities to come to that place where you can now start stacking and racking, because it's a quadratic. So I know A is negative 4, B is 4, C is negative 1, and D is B squared minus 4AC. I come out to be 0. So now I'm going to put it in the trig equation. So I have cosine theta in the quadratic formula is negative B plus or minus the square root of 0 all over 2 times A, or negative 8. Now I'm going to add and I'm going to subtract. So negative 4 plus 0 over negative 8, I'm going to get the same answer. I'm going to get 1/2 twice. Okay? So you only have to do one of these because they're both the same thing. So I'm going to set up my picture that I want you to do. I know cosine is positive in quadrants 1 and 4. Okay? So in my calculator, I do inverse cosine of 1/2. And when I do, I get 60 degrees. Okay, well, that's the quadrant 1, and then I got to take 360 minus 60. The other one is going to be 360 degrees. So those two are going to be our answers, 60 and 360. Okay, so I just want to do some with you so you can see how we do these. All right, let's look at this one. I've got 2 cosine squared theta plus 3 sine theta minus 3. I see sine, I see cosine, but this is squared, so I'm wondering if I can use one of the identities. So I'm going to go over to my sheet. Now this time I'm solving for cosine squared. See how I solve for sine squared here? So if I solve for cosine squared here, I'm just going to move the sine squared over. Now I know that cosine squared of theta equals 1 minus sine squared. So in the cosine squared, I can actually put this. And then my whole equation will be in sine. So let's go back here. All right. So now I have, ready, 2 times 1 minus sine squared theta plus 3 sine theta minus 3 equals 0. Distribute, so I have 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. Now, again, I'm going to put this in order. So this is going to be first, second, and I'm going to combine the negative 3 and the 2. So this looks very similar to what we just did, but I'm using the other trig function. So I have negative 2 sine squared theta plus 3 sine theta minus 1 equals 0. Okay, now we're set up. A is negative 2, B is 3, C is negative 1. And when I do my discriminant, my D, my B squared minus 4AC, I get a 1. All right? So I have sine theta equals negative B plus or minus radical 1 all over negative 4, because it's 2A. So we're going to split it up, plus and minus. When I do that, when I add it, I get 1/2. When I subtract, I get a 1. So now I'm going to draw my picture. So the first thing is I see sine's a half. So I know sine is positive in quadrant 1 and in quadrant 2. So when I put inverse sine of a half in my calculator, I get 30 degrees. So that's my first angle in quadrant 1. In quadrant 2, I'm going to do 180 minus 30, so it would be 150. So there's my second angle. So here's 30 degrees here. Here's 150. So that's taken care of. Now we're going to do the next one, where I'm going to do the inverse sine of 1. Now, when I put the inverse sine of 1 in, I get 90 degrees. So I look at that, I go, oh yeah, this is the 0.01. So it's going to be right on the quadrant. But I want to make sure that you check all the rest. So I look here, sine is 0 here, and it's negative 1 down here. So it is just going to be there. So I have 3 answers to this: 30 degrees, 150, and 90. So there's the 3 answers for that one. Okay, let's look at number 3. I have secant squared theta minus tan theta minus 1 equals 0. So I look at the secant squared. It's squared. I wonder if there's an identity. Let's come over to our sheet here. And now I have this identity here, which I will let you use this on the quiz, is I'm looking for secant squared theta. And I see that secant squared theta equals 1 plus tangent squared. So I'm all excited because when I put that in place of secant squared, my whole equation is going to be in tangent. So I have 1 plus tangent squared theta, because that's what secant squared is, minus tangent theta minus 1 equals 0. Now I'm going to put this in order, and the cool thing about this one is 1 minus 1 is 0, so I really have tangent squared theta minus tan theta equals 0. Now when it gets like this, I actually factor, because you could do the quadratic formula, but this is so much easier to factor. So I'm going to factor out a tan theta. When I do, I have tan theta minus 1 equals 0. Make your big T. I have tan theta equals 0, and tan theta minus 1 equals 0. So I have 2 equations. Tan theta equals 0, okay? And then I have tan theta equals 1. Those are our 2 things. All right, so let's do the inverse tan one first. I'm going to draw my picture. All right, this is a positive number, 0. Well, it's 0, so I'm thinking, where is tan 0? Well, tan is 0, and if you think about this, if I put in my calculator, inverse tan of 0, I'm going to get 0. Okay, which is fine. I get it right here because this is a 0.10 because it's sine over cosine. But it also, you have to check all of them. If I did sine over cosine, 180 would be 0. Okay, and I'm thinking, and I had to do back to 360. So I actually have 3 angles that go with this. I have 0 degrees, 180 degrees, and 360. All those 3 angles go when tan is 0. Okay. Now I have to do this one here, inverse tan, okay, of 1. And when I do, I get a 45 degrees. And I go, oh, that's positive. So tangent's positive here and here. So I see that it's 45 degrees here. And then I know here I'm going to do 1 180 plus 45, so I'm going to get 225 degrees. So I actually have 225 degrees. So I have two angles that go with this one, inverse tan of 1, and then I have three angles here that go with 0. Okay, so that's how I do number 3. Let's work on number 4. When I start number 4, I go, this one's different. I don't have any at all that are squared. So I'm like, this isn't cosine. I call that my building block. I wonder, can I write secant a different way? So let's look at our identity sheet. That's not what I wanted. Let's look at our identity sheet. So I'm like, okay, I know secant is 1 over cosine. So let's come back. So I have 2 cosine theta plus 1 equals 1 over cosine theta. I'm excited that it's all in cosine, but now I've got to say, what do I do next? Okay, so what we're going to do next is we're going to cross multiply. So I have 2 cosine squared theta plus cosine theta. So all I did was multiply cosine theta by 2 cosine theta. I got 2 cosine squared, and then that times 1 is going to equal 1. Then I see it's a quadratic, so I'm going to move my 1 over. So I have 2 cosine squared theta plus cosine theta minus 1 equals 0. All right, now I'm going to go through. I see it's a quadratic. I can do the quadratic formula. So I have A is 2, B is 1, C is negative 1. And when I do my B squared minus 4AC, I get 9. So I have cosine theta equals negative B plus or minus the square root of 9 all over 2A. Do my plus and my minus. When I do, I get a negative 1 and I get a 1/2. All right, so let's draw the picture. If it's cosine or sine, I get a 1, 0, or negative 1. I know it's going to be on the quadrant. So let's put this in our calculator. Inverse cosine of negative 1. And I know I'm doing the point because I know what it is. Inverse cosine of negative 1 is over here on the left, or 180 degrees. So it's right here on this because that's the point negative 1, 0. So I don't know of any other way because here cosine is 1 and I know it's 0 here and here. So it's only going to be that 180 degrees for that one right there. Now I have cosine's a half. I know cosine is positive in quadrant 1 and in quadrant 4. So if I do inverse cosine of 1/2, okay, I get 60 degrees. So I know this is 60 degrees. And then I do 360 minus 60, I'm going to get 300 degrees. So I have actual 3 angles that work for this one right here. I have 180, 60, and 360. All right, I'm going to do one more in this video. That's number 5. So I have 2 sine squared theta plus 3 cosine theta equals 0. I now see I can replace this. 2 times 1 minus cosine squared. We already did one like that using that one identity. Plus 3 cosine theta equals 0. So I'm going to distribute. I have 2 minus 2 cosine squared theta plus 3 cosine theta equals 0. Now I'm going to move them around. And so I have a negative 2 cosine squared theta because I have to have the squared first. Then the 3 cosine theta plus 2 equals 0. Now I can do the quadratic formula to find. So I have A equals negative 2, B equals 3, C equals 2. When I do my B squared minus my 4AC here, I get a 25. Okay, so now I know x equals, cosine theta equals, I started singing the song in my head, cosine theta equals negative B plus or minus radical 25 all over 2a, or negative 4. Plus and minus, when I do that, I get 2 and a negative 1/2. So I'm going to draw my picture here. First thing here, if I do inverse cosine of 2, I already know that's going to be empty set because if it's cosine or sine, you can't go above there. So thanks for playing. I appreciate your help. This one right here is a negative 1/2, so I'm going to use the trick Mrs. Pond said. I'm going to do inverse cosine of positive 1/2 because I know that cosine is negative in quadrant 2 and quadrant 3. So I want to do this to find my reference angle. When I do, I get a 60 degrees is my reference angle. That is not one of the answers because 60 degrees lives here in quadrant 1. So I'm going to take the 180, subtract 60, I'm going to get 120 degrees. And then I'm going to take 180 plus 60, I get 240 degrees. So we only have 2 angles that are for this one. So there's the first page of this lab. I hope that helps.